Just hold on till I start recording. Okay, Dooley, ready when you are.
Sure thing. Hello and welcome, and thank you for attending the very last presentation for today. We are Dooley and Associates, and we're responsible for the Braun Road Culvert Replacement and Roadway Reconstruction Project. HNTB were our mentors throughout the project, and we were helped explicitly by James, Matt, Kathleen, Josh, and Andrew. So my name is Kevin Karpinski. I co-opt at Kinley Horn and Associates with their land development team. During the 2 years I was there, I learned to create and compile plan sets for clients, primarily for multifamily complexes. I also applied for appropriate permitting to begin construction, including communication with the Illinois Historic Preservation Society, filing for a notice of intent with the EPA, and creating stormwater pollution prevention programs that contractors were obligated to follow during construction.
I'm Noah Cott. I majored in civil engineering. I co-opted with R.A. Smith, and there I created sewer plan and profile sheets, as well as designed some pipe networks in AutoCAD, and I also created road rehabilitation exhibits in ArcGIS.
I'm McGuire Korab. I'm studying civil engineering. For my co-op, I co-opted with Jacobs Engineering in Chicago. There I worked with the Intelligent Transportation Systems team. I primarily supported plan development and quantities, and I also supported roadway and urban planning teams.
And I'm Sean Townsend. I also am studying civil engineering, and I've worked for Superior Construction as a field engineer co-op. While I was there, I primarily specialized in bridge and roadway construction, and I also facilitated subcontractor coordination as well as oversaw all night shift operations. So a little bit about our project. Currently, Braun Road is a 2-lane rural highway in Mount Pleasant, Wisconsin. Our objective for the project is to expand the roadway to accommodate future traffic for Foxconn development in the area. It's anticipated that Foxconn will also be bringing increased industrial development in the surrounding areas around Braun Road. So our objective is, like I said, to expand the roadway and to also reconstruct the culvert over a small stream to withstand a 100-year design storm. We are also adding a detention pond to accommodate additional runoff from the expanded roadway. So for this project, we had 3 main sub-disciplines. Kevin and Noah handled the water resources engineering, McGuire handled the transportation engineering, and I worked with the construction engineering aspect of the project.
So these are the places that we collected a lot of the background information from the NOAA website. We collected all the rainfall data to model the design storms. From the Racine County map book, we gathered the elevation data in right-of-way locations. And we used the WISTOT facilities development manual for both roadway standards and pretty much everything, including the culvert design and the detention pond design. Then we used the WISTOT unit bid results for project-specific unit costs, and the WISTOT production rate table for the average production rates for construction operations. And then here is just an overview for all the codes and standards that we used for each specific subdiscipline. It included a lot of the facilities development manual, hydraulic design series for the culvert, the Wisconsin Department of Natural Resources for the detention pond, and the WISTOT standard detailed drawings for transportation. And here's an overview of the watershed of the culvert. It is approximately 740 acres, and it is divided into 12 different subbasins. Currently, all of this flows to the existing culvert, which is designed to withstand a 10-year storm. And because of the proposed development, we wanted to increase that to a 100-year storm. And additionally, due to the expanded roadway, there would be a lot of additional runoff from impervious land. And for that, we wanted to design a detention pond to withstand a 25-year storm. So for water resources, we had a couple different alternatives. For the detention pond, we were going to decide whether we wanted to use the 25-year average design storm or the 25-year upper bound design storm. And the difference between those is the average storm had a 90% confidence interval, while the upper bound design storm had a 95% confidence interval. Then for the culvert, we were deciding between a single barrel and double barrel culvert and whether to use cast in place concrete or precast concrete.
So I'll elaborate a little bit more about the water resources design choices for this project. Obviously, we're deciding on the detention pond and the culvert. And I'll discuss the culvert first. There were a total of 4 parameters that we had to choose from. So we were deciding between a cast in place and a precast culvert. And we were also deciding between a single barrel and a double barrel design. We decided that the cost and ease of constructability were the 2 most important decision criteria for Foxconn's sake, who's going to be on the site, and were awarded the heaviest weights. We also considered sustainability and the hydraulic capacity in our designs. A precast design was selected over the cast-in-place design due to how quickly it could be constructed, and a double-barrel culvert was chosen due to the availability of construction phasing, which Sean's going to touch on a little later on in the presentation. As far as the detention pond goes, we were forced to choose between a 25-year average design storm and a 25-year upper boundary design storm. Because our client did not show any concern or kind of specify which storm should be used in design, we chose the average design storm as being appropriate for this project. This allowed for significant cost savings for Foxconn and also allowed for an easier and quicker construction. Should Foxconn have decided to settle with the larger design storm, there would be a larger storage volume, and there would be much more stress on the construction team to complete the project within the single construction season that they were allotted.
So here is an overview of the final hydraulic design of the culvert. It is comprised of 2 8-foot by 6-foot barrels. It is 204 feet long with a 0.59% slope. The tailwater was modeled in Heckras, and the cross section you can see on the bottom left there. And as you can see, the tailwater was estimated to be approximately 732 feet. And for the rest of the hydraulic calculation for the culvert, we use the culvert design form on the Hydraulic Design Series 5. And we estimated the headwater to be approximately 734.68 feet, which is significantly below the crown elevation of the roadway.
So I'll talk now a little bit about the design of the detention pond. We decided that there was an ample amount of relatively flat land south of the roadway to place the detention pond. The northernmost corner of the detention pond is 75 feet away from the proposed shoulder of the roadway. The calculated surface area was about 21,000 square feet. However, that elicited a depth that was considered too deep in terms of safety. It was close to about 14 feet. So changes were made to implement a safer depth. We decided to expand that surface area to a little over 29,000 square feet. So that depth from the top of the permanent pool surface area to the bottom of the pond was reduced to the minimum of 3 feet. To determine the required storage volume, we used the WIS DNR conservation practice standards and found that the runoff volume had to be about equal to the storage volume. So as you can see on the screen, the required storage is just below the designed actual storage volume. So this is a very simple cross-section of the detention pond. It's typical at any given place. The FDM mandates that a 3-to-1 slope be used above the safety shelf and a 2-to-1 slope be used below the safety shelf. So these ratios are in horizontal to vertical, by the way. And the FDM also made sure that this pool had at least 2 feet of sediment storage because the permanent pool surface area was above 20,000 square feet. And so if we had made the permanent pool surface area below 20,000 square feet, we could have used a lower volume of sediment storage instead.
So for the transportation alternative, we were tasked with designing a roadway to accommodate the projected traffic. Our design was to focus on the future roadway expansion via additional median lanes. The two final alternatives proposed included a 50-foot and 60-foot median. The figure shown is a typical roadway section from the WISDOT Facilities Development Manual. And also shown is the current and future ADTs. So comparing the two alternatives, we found that we could expand the roadway sufficiently with the 50-foot alternative at a reduced cost, as a larger median would require more earthwork. The figure below depicts a typical roadway cross-section. All design characteristics were derived from the WISDOT Facilities Development Manual. The roadway features 4 12-foot lanes with grading as shown. The travelway consists of 10-inch concrete pavement, a 6-inch base aggregate, and 16 inches of select crushed material for the subgrade improvement. Additionally, to depict the future possible expansion, we have our proposed 6-lane configuration compared to the 4-lane configuration. The roadway features an additional 12-foot inside lane along with the underdrain along the median. The project also required that we include curb returns for future intersections. These roadways were named Foxconn 1 through 3 and are shown here in our proposed corridor. To the right, we have a typical intersection layout designed to accommodate a WB62 truck.
Okay, so on the construction side of things, as the other guys kind of alluded to, two of the biggest alternatives that we had to consider were cost and schedule impacts. Some unique features for this project were, first, that the entire project needed to be completed start to finish within one construction season, so between April 1st to November 30th. And we also had to maintain 2 lanes of traffic throughout the duration of the project. So in terms of cost, this impacted the project because we had to implement 2 phases. So anytime we're implementing more than 1 phase, we're obviously going to see a rise in cost because the contractor has to mobilize and demobilize in between each phase. So that was something we had to be conscious of. But we also looked at concrete pavement versus HMA pavement in terms of design life, construction costs, and also maintenance costs into the future. Then, as Kevin kind of talked about, we did look at the box culvert construction, whether we wanted to go with a precast culvert or a cast in place, as well as how are we going to do this while maintaining traffic. So can we do it in 1 barrel? Do we need to go to 2? That's something we were considering. And we ultimately ended up going with the precast culvert because of its schedule implications. We didn't have to eat into our schedule to form it up and pour it. So that was a big thing on our side. And this is the decision matrix that we use to actually score the design alternatives. Like I already said, the schedule impact and the cost were weighted the highest. The ease of construction also played a factor due to the fact that we were dealing with a stream that we could not completely block off at any time. So we were actually planning on using PZ sheets to divert the stream into each barrel so we would have phasing for the roadway, but also phasing for the culvert and how we would construct that. So yes, in summary, we did go with the concrete pavement. It's a 10-inch pavement, and we did go with the precast box culvert. The reason for the 10-inch concrete pavement was the increased design life. While there is some more upfront costs involved, we determined that the maintenance costs were far less than an HMA alternative. And we were also considering how truck traffic would influence the pavement design. So we chose the concrete because it did have more durability as opposed to the HMA design. When we were looking at the precast culvert, as I mentioned before, the schedule impact was very, very important to us. And it also minimized the stream disruption. And doing the 2 barrels allowed us to keep both lanes of traffic open at all times throughout the duration of the project.
Just to kind of recap, the final design selections for each subdiscipline are shown here. The project came in around $6.1 million with an expected duration of 244 days.
And so in addition to the presentation and the final report, we will also be turning in a hydraulic analysis report, a cost estimate, a plan set, and a project schedule. And that concludes our presentation. Thank you very much for listening, and we'd love to answer any questions.
Okay, thank you, Dooley and Associates. We have some of your mentors online, so I'd open it up first to questions from Kathleen or Matt or James.
So I have a question. In dealing with your design and you guys meeting together week to week, and then all of a sudden we had this COVID pandemic, was there anything that you needed to do with your schedule? Because you had a design schedule. Was there anything that you needed to do to adjust, and how did you accommodate all of that in order to meet your deliverable?
Sure, I can speak to that. So with the disease, our design schedule obviously was pushed back quite a bit. We ended up basically, after meeting with HNTB and just kind of talking it through with them, we had kind of decided to reevaluate our schedule, accelerate certain portions. Some information we were kind of nudged in the right direction for certain design criteria. I know for transportation there were certain elements that we were basically nudged towards, and I'm sure water resources had the same thing. But overall, it was just kind of a collective effort of coming back together, reevaluating the time we had left and the resources available to us, and kind of just going from there.
Any other questions from the mentors? Okay, hearing none, I'll open it up. Any questions from faculty members? Young, I see you have a question. Why don't you go ahead?
Yes, my question is also related to scheduling. Have you developed the schedule, preliminary schedule? Because I didn't see any chart or things presented in your PowerPoint.
Yeah, we have that done. The reason it wasn't in is just because it has so many elements in it, and it's 244 days. So if I were to put that up on the PowerPoint slide, you wouldn't be able to read anything. But it's definitely something we have ready to go for our final deliverable for next Friday.
What software do you use?
I believe it was the Microsoft project.
Okay, good. The leader, I guess my suggestion is there is a way that you can use Microsoft project to do a summary project. So that will condense to maybe a page that you can show on the PowerPoint. So that is something that you can look into it. I know the function is available. So basically, you can show based on months, for example, within 12 months. Your schedule is 260 days, so it's less than a year. So you can condense to a month's phase, and then you can have a summary schedule that you can show, put in your PowerPoint. So that's just a suggestion for your future.
Yeah, and I should have elaborated on it more, but a vast majority of the project is related to the roadway just because it is so long. It's was about 8,200 feet long, and it's a very big fill operation. So I'd say 75% of the schedule is related to embankment and subgrade improvement, stuff, and pavement. That's a vast majority of it. The culvert, while it is 204 feet long, we're able to stage it so that it's only about a month per phase.
Okay, good. Thank you.
Jaime, do you have some questions?
Yes. If we can go back to the slide where you were showing the decision matrix with the scoring and the options. Here, when comparing the concrete pavement and the HMA, I see a difference in sustainability very significant between 7 and 3. So the question is, what criteria was used to deem concrete pavement more sustainable than HMA pavement?
I can take this one. The main reason was the maintenance costs. With the analysis that we did, we saw the HMA was going to require some sort of overlay in the foreseeable future. And again, with such a long stretch, and being that HMA is an oil-based product, we foresaw that as having a greater impact down the road, in term not only in just the material, but also the construction operations related to overlaying it. You got to mill it, put the tack coat down, and then so you have all of this equipment and trucks running at the same time. Whereas the concrete pavement has a much longer design life that is going to require a lot less maintenance, especially being in Wisconsin where we have salt on the roads and the roads do deteriorate very quickly.
But wouldn't that be in the column of cost?
It was. But I think what we were going off of was oil prices at the time, being that HMA, it's a little bit faster to put down, but I think that cost also takes into account the maintenance as well, whether that be like filling joints or cracks as they arise.
The reason I'm asking is because I think this table is great because of multiple reasons. The first one is all these factors are related to each other: the cost, the sustainability, and also the social aspects. But focusing only on the cost and the sustainability is very hard to talk about one without talking about the other one. That is one thing. The other thing is and this is just for your future reference. The answer is not such as it's lower maintenance, so it's more cost effective. Remember, 98% of the roads, 98% of the paved roads in the US are flexible pavement. That doesn't mean it's better. That means it's just there must be more, and there is actually more into it. And one of the reasons, and actually the other group talked a little bit about this, is the initial cost. The initial cost of building a concrete pavement is higher. And there is another aspect in the sustainability. Producing asphalt cement is very energy intensive. And that's also something that needs to be included with doing this kind of evaluation. With that being said, it's not that there is a definite answer, because this is a very, very, very active topic of research right now, and I just wanted to raise that point.
Okay, thank you. Walter, did you have questions?
Yeah, great job, y'all, on your presentation. I can tell you guys did a lot of work between the last time y'all presented your update and now. My question is just about your detention pond. So you guys did a good job of designing that, and I was just curious. I didn't recall seeing if you guys had mentioned what the outlet structure was, or if you guys had designed that, or how you did it. Could you kind of speak to that some?
Yeah, I can answer that. So the outlet structure was just a pipe. It probably would require some more detailed design work and an actual construction plan set, but that was not within our scope. We did size the outlet, however, to be a 6-inch pipe, and that was just gathered from using the Hayes and Williams equation.
Okay, thanks.
Yep.
Okay, any other questions for Dooley and Associates? Okay, hearing none. Thank you very much, Dooley and Associates. Good job. And with that, we've concluded all 10 project presentations, and just an outstanding group of presentations, outstanding work by all the groups involved, especially given the COVID difficulties that have arisen this semester. Really did a fantastic job. I'm so happy to be part of this group and this class. It really was an honor to be involved. So with that, we will tune out. I will send an email with updates on where you can find the recordings of your presentations online. Again, if anyone doesn't want it to be posted, they should email me today or tomorrow so I can make sure that doesn't happen. So thank you all. Thanks to all the professors who participated. Thank you to all our mentors that participated. That's a huge job that helps us out. And of course, thanks to all the students that did a fantastic job. So with that, we'll be tuning out, and thank you all very much.
Thank you kindly.
Thank you.
Thank